In this video, we will do accuracy assessment of classified image. The first step would be to add ground truthing data, which is in ddata.shp file. So we will load that data. So this data is basically those points which we have taken on the ground, and we will see the attribute table. So it has been coded which class it is. So if it's water, we have coded it as 1. If it's agriculture, then coded as 2. If it's built up, coded as 3, and if it's barren, coded as 4. Now let's add the classified image from the lab 17. So we will add this classified image SC Nawabshah. So now this is our classified image, and we can bring our ground truth data above it, change a little bit symbology just to see it. Now zoom out, full zoom it. Now this is our ground truthing points, and these are the points which we will develop error matrix of. So now let's go to the second step. Now what we have to do is, for each point we have to extract the values from the raster. To do this, we will use tool extract values to point. So we have to go into a spatial analysis tool, extraction and extract values to point. So we will go into spatial analysis tools. Let's go in spatial analysis tools. Then there is a toolbox called extraction. From extraction we will get extract by points. Just to check it again, extraction, extract values to point. So we will select extract values to point. So extract values to point. Double click it. So now it will ask input features. Our input feature is gdata. Our input raster is SC Nawabshah. So there will be extract shapefile, so we can put it into the create a new result folder and put it there into the result folder. So we can name it, let's see what we are naming, so predicted.shp. Save it and press OK. So it will extract values from the raster to the point data file, point shaped data file, and save it as predicted. So in predicted we will see an attribute table. So we have this gtruth data or the ground data, and here we have the predicted data in our raster value column. So now let's go and add one column into a predicted.shape file. Name that column as predicted, and you can enter the values or using the raster calculator into the predicted value. So let's do it. So I will introduce another field. Add field, name it as predicted, and I can check again. So it's predicted. Give it a double and press. Let's see what data type we are using here. So to be consistent, just make sure that select double, field properties, put 4 and 4. That's okay. You can put 4 here, 4 here. Has to remain consistent. So press OK. Now you can use raster calculator. Go to the raster calculator or field calculator. Now we will use field calculator, and we will make sure that it is equal to our raster value so that our column has a name. So now predicted is there, so now these two columns are same, so we can remove this raster value column just to avoid duplication. So now you can see that the information we need for creating error matrix, we have both of this information. So we have gtruth data, which is ground data, so it tells these cells are water, and then we have predicted data from the raster classification. So 1, 2, 3, 4, 5 are the same class, but 5 pixels are or reference size are of the same class as water, but then there is like 3 and 4, which is different classes. So now let's calculate calculate the total numbers. We will use frequency tool for doing that task. So we will use frequency tool to check how many prediction match with the field data points. So to do that, we will use Arc toolbox, analysis tools, statistics, frequency. In that frequency, we will put input predicted as an input, we will put output as a frequency, and we will check gtruth and predicted in the frequency fields and press OK. So let's do it. So we have to go into Arc toolbox, analysis tools, statistics, and frequency. Statistics and frequency. Double click on the frequency. Input table is your predicted table. Your output table, so what we are naming output table is frequency. We will name it as a frequency. Press save. And now what we have to select is gtruth and predicted as frequency fields. So gtruth and predicted, and then we'll press OK. So now let's press OK and see what output is we are getting. So this is the table you will find into the Geo database. So we can open it and see. So now it has the frequency for each class. Now to getting the frequency, we will rearrange this all data into error matrix format, into row and column format. So to do that, we will use Arc toolbox, data management tools, table into pivot table tool. So we'll go into data management tools, table and pivot table. So close it, go into data management tools, tables, and then we'll go to a pivot table. So once you have selected a pivot table, now what are the input? So you will put input table as a frequency table. So I will input table as a frequency table. Now it will ask me input fields. So predicted will be an input field. And then it will ask me about the pivot field. So pivot field is gtruth. And then it asks the value field, so we'll put value field as a frequency. Now how we will save it is table output as an error matrix. save it at the same place. So we will save as error matrix. We will press OK. So now you can see the error matrix. So now our error matrix is arranged into the format as we want it. So it gives you diagonal values which are correct, and then it gives you the commission error and the omission error fields. So now what we can do is basically you can edit it here, like putting the names to each class, or we can just simply do all the other stuff into an Excel sheet. So what I will do is basically export this into .dbf format or CSV format, table into a CSV format or database format, and then I can calculate all other statistics as we calculated in previously in other video you saw. So let's export it. Let's see. We'll export this table. This file I will save it in. Okay, now let's see. Results. Here it is. Oh, it was previously also there, but we were not able to find it. Let's open it into an Excel. We'll go to open. So next, it's comma limited. Finish. So here we have this 1, 2, 3, 4 row IDs. So we know that our one is last time what we did into supervised classification. We knew what our one was, the water, so we'll put water here. So our two was agriculture, I remember. This we already know it when we classified, so I just cross-checking it. So it's agriculture. Water, agriculture. Then our 3 is build up. Let's check it once. Yes, it's build up areas. So I will put build up here. And then we have 4, which is value. So now we know that this whole information we don't need now. This information we will delete it. And we know it's water. No, it's agriculture. We know this is built up, and we know this is barrel level. Now all of our information is there. Now just to Okay, we can save it as an Excel file. So I will save it into result folder and I will save it as an Excel workbook. Now you can sum up, do a total here. So I will do a total here is equal to, oh sorry, I will do a total here. And I will do total here. It's 29, and just to check if the number is okay, we can see the it's 29 reference sites. Total reference sites are 29. So now what we have done is basically calculated or developed an error matrix. Now you can calculate the statistics. Commission error. Here we have commission error. Now we have producer accuracy. We have user accuracy. And then we have omission error, producer accuracy, user accuracy, and we have overall accuracy. And then last we have Kappa coefficient. So let's format it a bit. Because I know what is the data and what are the statistics calculated. So what is omission error? Omission error is the fields which we omitted. So this all three, like, we need to add them up. So, or I will do individually so that you can recognize. So it's 0 plus 1, 2 plus this divided by the total gives you an omission error. Now again here you have an omission error, this plus build up plus barren divided by the sum. Press enter, then we again have omission error here, this plus this divided by the total sum of the build-up reference classes, enter, and then we have barren land, this plus this divided by the total barren land values, so you get the omission error. Now we need commission error, and for commissioning error you will calculate, you will add all this plus this, and then there is like plus 0 plus 0 plus 0, it doesn't matter, but we are just for the sake of understanding doing it. Then we divide it by total, then we do again this plus this plus this, bracket close, divided by this value. So we again do this build up plus agriculture plus barren land divided by 8. Now final for the barren land, this plus this plus this, bracket close, and then divided by total number. So it's your commission error. So we will calculate user accuracy 1 minus commission error. So your user accuracy, your producer accuracy 1 minus omission error. Now what we will do is calculate overall accuracy. Overall accuracy is the sum of diagonal values. So we'll put into the divided by reference sites. Some of the diagonals are there, all the diagonals B2, C3, B4, and then E5. Press enter. So your overall accuracy is 65%. Then you will calculate Kappa coefficient, and Kappa coefficient is, first you need to calculate your random accuracy. For doing so, we will put this formula is divided by 29 all reference sites. Then we multiply it 8 divided by total reference sites. Make it close. We can close it more. Then we will add the similar thing for other stuff. So it's a mistake here. B6 divided by F6. Here should be a B6. That's a mistake because it's the same class we are working on. Now it's okay. So B6 divided by F6, and oh sorry, should be this value F2 divided by F6. Yeah, now it's okay. This value, okay, good. Now let's do for other classes. Let me see if my all brackets are closed properly. Yes, they are closed. Now let's do it for other class. So it's C6 and F3. That's okay. And plus it's B6 divided by F6 and F3 divided by F6. Then we will add one more, which is basically E6 divided by F6, and then F5. Yes. Why it has this 6 value? Sorry, that's the mistake here. F2, 3, 4, 5. Okay. Now we have calculated this random here. So what I will do is basically PA, which is overall accuracy, minus PR, random accuracy, divided by 1 minus PR. So this is your Kappa coefficient. So your Kappa coefficient is now calculated. Press enter. So it's like 0.54 is your Kappa coefficient. So you can see here what classification scheme we did and what range it lies. So 0.54 is moderate classification. It lies into a moderate classification range. So I think you have understood this, how we can calculate. So let's try by yourself and see how your classification scheme performed.